Today we'll discuss on the decision on why do you use thin wall or thick wall, and how does the d over t formula actually help us to differentiate between thin or thick wall. Alright, the reason why we use thin wall is because the formula is really easy. Alright, if you can generalize all walls, if it's thick or thin, we can use this good. But however, this equations is limited only to thin wall. However, if it's talking about thick wall, things start to get a little more hairier. Alright? And therefore let's do a few examples and see how things goes, right? We may attempt to do this question, but I'll not just read it out, but just take out the relevant stuff. Alright, we have a 48 inch outside diameter. So our outside diameter is about 48 inch. Okay? And that we have a for inch to millimeter is actually 25. So 48 times 25, alright, is your millimeter stuff. Alright, and we have a wall thickness of 18 millimeter, so T is equals to 18. Alright, so 48 times 25, because it's the conversion from inch to millimeter, this is the 25 divided by 18. What you have is actually 33.33. Okay, so with calculation of because you know that your ultimate diameter is actually 48 times 25, which is about 600 mm, minus away your 18, because it's your thickness, right? This is your thickness, this is your outer diameter. Please take note of the understanding that this is the outer radius that you're going to use. So normally when you're going to use in terms of the outer diameter or outer radius, so to speak. Alright, please be very careful about that. For such the case that happens, we will have 582 as the inner radius. Alright, so far so good. We have been talking about the 48 inch is the diameter. Alright, 48 divided by 24 is your divided by 2 is your radius. So this is why they sub in as 24 times 25. Okay, but anyway, I just want to convey certain stuff, just hang on a bit. Alright, so this is your interior radius, this is your 600 is your or 0.6 is your exterior radius. Alright, so now we're gonna analyze in terms of certain stuff. Alright, we know that this thing over here is in terms of a thin wall system. Alright, this is in terms of thin wall system, but we actually go and do on thick wall and see how does this thick wall theory actually helps to relate to the thin wall. Right, so we know that sigma r, the radial stress, is equal to the outside pressure, if you still remember. So the outside pressure is actually 94 bar. Alright, 94 bar, and therefore it's over here, and it's negative 94 MPa is because the outside pressure is, you have a cylinder over here, the outside pressure is coming in towards you. Alright, it's negative. If it's going out, then it's like positive and things like that. But in our case, I'll just take it as or in other words, at the surface, just at the thickness itself, sigma rr, it's going in this direction. Then the counter force is actually, the counteracting force is actually the pressure that is outside, if you were to so to speak. Right, but you now apply the sigma theta theta, your own formula that we have derived. While you sub in r square now, instead of any r, you just sub in as ri square. Alright, because we want to calculate in terms of internal radius and external radius and see how the results will be compared. Alright, if you do that, you can just cancel, and then the rest you calculate, you will get this thing. I'll not do that because it's just simply subbing in your outer radius and your inner radius and things like that. So therefore, it's kind of straightforward. Alright, same thing for your sigma zz. Alright, it's this long chunk of stuff. And then now for thin wall is just this particular formula. I'll just simply sub in my pressure, which is 9.4, and my radius, alright, 0.6 for the outside one. So I'll have this whatever values that is. Alright, then I'll just sub in thin wall also, but in terms of an internal radius. So just now I sub in as a external radius. Alright, so now we sub in the internal one, and we have these values over here. Then we're gonna compare now. So how do we compare? this sigma RR, alright, our so-called the radial stress is minus 9.4. We don't care because if it's minus, then it's not our business already. So therefore 0 is adequate enough already, right? Over here for thin wall. This is thick wall analysis. Now, if you were to analyze the hoop stress 308 and 313, the percentage difference is actually kind of maybe 98%. Alright, so there will like 2% error only. Alright, same as the rest of the combination if you compare. Alright, 156 and 150 and 152 also. You just compare all the numbers. The error may be about 2% up to maybe 4% maximum, I think. So therefore you can just straight away use thin wall straight away. We don't need to apply thick wall. Alright, but however we cannot apply thin wall to the thick wall system. Alright, so how does the thick wall system works? So we have still all this stuff over here. You can just read it out if you're free. Be careful of the meter and the cm and things like that, or the inches. You need to really know how to so-called articulate. But I'll just do in terms of the d over t, or in other words r over t. So now we also talk about the outside radius. Alright, the outside diameter, or in other words. Alright, you have this value 6.7, and we know that this is actually a thick wall, right? Anything larger than if d over t, alright, anything larger than 10 is considered thin. Alright, if it's smaller than 10, alright, then it's considered thick. Alright, whatsoever, okay? But so we see that this is actually smaller than 10 now. Right, but in fact, anyway, let's continue first. We have all this external pressure, I would believe. Hold on a while. I think now this is the interior pressure, because we only use one pressure in this question, either, right? So because, so to speak, we only use one pressure, and therefore we are actually ignoring that the external pressure is actually equals to 0. Right, normally we assume that the external pressure is equals to 0 if you remember how we derive all this equation. Alright, the external pressure is actually equals to 0. But anyway, let's continue first. So same thing, you just sub in whatever stuff you have. You just sub in your internal radius. Alright, you'll get your own numbers. Just sub in all the numbers. Same thing. Alright, now this is actually this is for thick wall when you sub in the interior radius. Now you sub in thick wall, sorry, where am I? Thick wall for the outer radius, and you'll get all these numbers. It's just simply subbing in, alright. But make sure when you sub in, when your r square over here, you sub in as r naught, alright. I mean r out. If it's r square over here in terms of the inner radius, then you can sub in as ri square, alright. So r square will become ri square. So this is something that you need to take note of. Because this is just simply applying formulas, and that's all. Alright, and therefore you have all this, and in fact this is now the thin wall theory. So thin wall theory, I apply the outside radius. I have this formula. This are my equations. Then thick wall, I sub in my internal radius also. So I just sub in all my internal and exterior radius, and then we compare the differences. Alright, now this is the comparison between the thick wall. This part over here is thick wall. This time over here is thin wall. Alright, and normally if you want to ensure that the cylindrical vessel is safe, alright, your fracture toughness, right, is gonna be larger than your stresses that is acting on here. Alright, must be larger than your largest value. In this case is 156. Alright, but let's continue first. If you were to compare 156 and 142, alright, 142 divided by 156, I would have 1%. I have a 9% error. Alright, if I were to compare 66 and 71 in this case, what will I have? 93% error, or 93% similarity but 7% error. Alright, you can also compare with this value 131 and 167. Then you'll be like, really seriously, I think it's 78%, which is 22% error. So therefore this examples prove that you cannot use thin wall to estimate thick wall, right? Because the error is simply so big. Alright, so thick wall you use thick wall, thin wall you use thin wall. Alright, and therefore this is just something that I just want to convey over here. You just take note that when you're talking about the diameter over the thickness, please use the outer diameter, or the outer radius divided by t. Alright, and then lastly is that we see that dot, alright, is equals to it must be larger or equals to 10 in order for so-called the for it to be thin wall, right? For it to be thin wall. Now, so the diameter is actually 2 times r0 outer, alright, you see, is equals or larger than 10, and then I'll just bring this 2 downwards, so I have 5. So if you're larger than 5, that means that you're gonna use thin wall, alright. So if you're actually smaller than 5 for radius, then you're gonna use a thick wall, okay. However, just now when we use this equation, our thick wall is actually 6.7, and therefore can we consider it as thin, alright. And this is also something that I want to raise awareness, is that in the outside world, I mean in other websites, the O over T is actually larger or equals to 20, alright, it's not equals to 10. But I think because maybe strictly speaking you have to ensure that things are safer, so therefore you choose 10 as your safety zone. I don't know, leave you to think about it. And this settles everything about the thin and the thick wall stuffs, and I shall see you soon in some examples.